Hello, and welcome to Sleepy Science by Nem Vita. Whether you're listening at the end of a long day or simply letting your thoughts slow down, this is a place where curiosity unfolds gently. There's nothing you need to solve, nothing you need to remember, and nothing you need to focus on. If you find your attention drifting, that's perfectly fine. Let the words become a soft background, and let your body settle into rest. Allow your breathing to soften, slow down, and become quiet, steady, and easy. I'm glad you're here. Take a long, slow breath in. And as you exhale, imagine the modern world beginning to fade away, replaced by the deep, crystalline silence of a winter night. You are standing at the edge of a wide wooden porch, sheltered by the overhanging roof of a sturdy glass cabin. Before you lies an untouched landscape of white, stretching far into the shadows of a pine forest. The air is crisp and sharp, but you are wrapped in layers of wool and warmth, feeling only the refreshing touch of cold against your cheeks. Look out into the twilight. The sky is a deep, velvety indigo, and through the stillness, the first flakes of a heavy snowfall begin to descend. They do not fall like rain. They drift, weightless and unhurried, as if the air itself is holding them up. Each flake is a masterpiece of soft physics, a tiny, frozen traveler completing a journey that began miles above you, in the freezing heights of the atmosphere. As you watch, you notice a profound change in the atmosphere. The usual sounds of the forest, the rustle of dry leaves, the distant snap of a twig, have vanished. They have been replaced by a hush so thick it feels like a physical blanket pressing gently against your ears. This is the first lesson of the snow. The science of silence. Freshly fallen snow is exceptionally porous, filled with tiny open spaces between the lacy arms of the crystals. These microscopic air pockets act as natural acoustic traps, catching sound waves and absorbing them before they can echo or travel. The world is not just quiet. It is being actively silenced by the velvet texture of the snow. When a sound wave from a distant bird or the low hum of wind enters this porous labyrinth, it bounces from one ice crystal to another until its energy is exhausted, transformed into an imperceptible trace of heat. The snow does not just block sound, it consumes it. You step back toward the large glass door of the cabin. The light from the fireplace inside spills out onto the porch, turning the falling flakes into sparkling embers of white. You can see the intricate geometry of a single flake as it lands on the railing, a perfect six-sided star, reflecting the internal order of water molecules as they bonded together in the cold. It took nearly 45 minutes for this single crystal to form and fall to this spot, shaped by every slight change in temperature and humidity it encountered on its way down. The door glides open silently, and you move back into the warmth. As you settle into your chair by the window, you realize that out there in the dark, a billion tiny miracles are landing every second, each one adding to the thermal blanket that will protect the Earth until the spring. You are safe. You are warm. And the silent science of the winter night is just beginning to unfold. Deep in the high, freezing reaches of the sky, where the air is thin and the clouds are heavy with cold, the story of a snowflake begins. Not as ice, but as a single microscopic speck of something terrestrial. It might be a grain of ancient desert dust, carried on winds from thousands of miles away, or a tiny fragment of volcanic ash ejected into the stratosphere decades ago. Perhaps even a fleck of pollen lifted upward by a summer thermal and frozen in place. This is the nucleus, the heart of the star. And without this tiny anchor, the water vapor in the clouds would have nothing to cling to. The science of this beginning is a slow, quiet miracle of molecular attraction. In the supercooled air of the high atmosphere, typically at temperatures between -10 and -20 degrees Celsius, water vapor molecules are moving lazily through space, searching for a home. When they encounter this microscopic nucleus, often no larger than a bacterium, they begin to settle upon it one by one, forming a tiny, invisible bead of ice. It is the start of an architectural process that follows the most fundamental laws of the universe. Because of the specific way water molecules are shaped, with their hydrogen atoms forming a 104.5-degree angle from the oxygen atom, they naturally prefer to bond in a hexagonal pattern. This is not a choice. This is a six-sided geometry that dictates the shape of every snowflake that has ever fallen or ever will fall. You lean back in your chair, watching the firelight play against the window pane, and you think about those billions of microscopic anchors floating miles above the cabin. Each one is the foundation of a masterpiece. As more and more vapor molecules find the nucleus, the crystal begins to grow outward, sprouting 6 delicate arms that reach into the moist air. This growth is not a hurried event. It is a patient expansion, governed by the exact temperature and humidity of the cloud. If the air is very cold, around -15 degrees Celsius, the arms grow thin and needle-like, forming what scientists call columnar crystals. If it is slightly warmer, closer to -5 degrees, they become broad and plate-like, forming the classic star shapes we see on our sleeves. Between these temperatures, at around -10 degrees, conditions are perfect for the formation of those intricate stellar dendrites, the most beautiful and complex of all snowflake forms. As the crystal grows, it becomes heavier, gaining mass molecule by molecule, until finally the gravity of the Earth begins its gentle pull. The journey from the clouds to the forest floor is a slow drifting descent that can take nearly an hour for a single flake to complete. During this long fall, the flake is constantly changing. It passes through layers of air with different humidity levels and varying temperatures, and each change adds a new layer or a new branch to the crystal. This is why the science tells us that no two flakes are ever truly identical. The specific path that one flake takes through the sky, the exact sequence of updrafts and chills it encounters, is a unique history that can never be perfectly repeated. Even two flakes falling side by side will experience infinitesimally different conditions, resulting in subtly different structures. Each snowflake is a physical record of its journey, a frozen diary written in ice. You take a slow sip of your tea, the warmth contrasting with the thought of that high, cold laboratory in the sky. Millions of these unique histories are settling onto the roof of the cabin right now, each one a silent record of a journey through the atmosphere. They are the children of dust and cold, vapor and time, coming together to form the white silence that now surrounds you. There is a profound peace in the knowledge that such complexity can arise from such a simple beginning, that the world is being rebuilt flake by flake, crystal by crystal, while you sit in the safety of the glow. The molecular dance continues above, slow and patient, governed by physics as old as the planet itself. Inside the warmth of the cabin, the fire continues to pulse with a low, rhythmic glow, casting soft amber light that reaches toward the frosted corners of the large glass windows. You lean your head back against the cushion, closing your eyes for a moment to simply listen to the silence of the storm. When you open them again, your gaze is drawn to a small cluster of snowflakes that have landed just on the other side of the glass, held there by the static electricity of the cold. Here, in this close-up view, you can see the results of the hexagonal dance, the fundamental geometric law that dictates every frozen structure in this forest. The science of this shape is not accidental. It is a deep structural necessity, written into the very nature of water itself. When water vapor begins to cool and slow down, the molecules, each one consisting of 2 hydrogen atoms and 1 oxygen atom, begin to look for a way to connect. Because of the specific angle of these atoms, they cannot just stack like bricks in a wall. Instead, they are forced by the laws of chemistry to bond in a very specific 6-sided ring. Imagine a vast invisible ballroom in the sky, where every guest must hold hands in a perfect hexagon to maintain balance. As one ring forms, another attaches to its side, and another below it, building a crystalline lattice that is as light as air, but as ordered as diamond. You watch the firelight catch the edges of the flakes on the glass, and you realize you are looking at the visible face of the universe's most basic physics. As these 6-sided rings stack, they begin to push outward from the center, forming the arms of the snowflake. These arms, called dendrites from the Greek word for tree, always grow from the corners of the hexagon. This is why every classic snowflake has exactly 6 branches. It is a mathematical certainty, a rhythmic repetition that happens billions of times every minute across the dark blue sky. Even as the wind tosses the flakes and the temperature shifts, the water molecules never forget their geometry. They always return to the 6-sided dance. This happens because of hydrogen bonding, one of the strongest intermolecular forces in nature. Each water molecule can form up to 4 hydrogen bonds with its neighbors, and in the solid state of ice, these bonds naturally arrange themselves into the hexagonal pattern that minimizes energy and maximizes stability. The beauty of this science lies in the infinite variation within that strict 6-sided rule. As you watch the soft white layers accumulate on the porch railing, you think about the synchronization of the bonding process. Each arm of the flake is growing independently, yet they all grow in nearly identical patterns because they are all experiencing the same microenvironment at the exact same time. If a sudden puff of warmer, moist air hits the flake, all 6 arms will widen simultaneously to form a broader plate. If the flake falls into a pocket of drier, colder air, all 6 arms will sharpen into needles at precisely the same rate. It is a symphony of synchronization, a silent communication between molecules separated by distances 1,000 times their own size, yet perfectly coordinated through the physics of their shared environment. environment. The light from the hearth creates a spectrum of colors within the ice, tiny flashes of prism-like rainbows that appear and disappear as the flames flicker. You are witnessing the interstitial spaces of the snow, the gaps between the crystal lattices where light is bent and slowed. These gaps are not just beautiful, they are functional. They are the reason the snow feels so light and why it can be compressed into a more solid mass. When you think about it, a snowbank is mostly made of air. About 90% of its volume is nothingness, held in place by the strength of those tiny six-sided connections. This is what makes fresh snow such an excellent insulator. The trapped air cannot circulate or conduct heat efficiently, creating millions of tiny thermal barriers that protect whatever lies beneath. As you settle deeper into your blankets, the concept of this molecular order acts as a grounding force for your mind. There is something deeply reassuring about the idea that even in a wild winter storm, there is a perfect underlying structure. The world is not falling apart. It is being built with precision, crystal by crystal, according to laws that have existed since the first time water froze on this planet, billions of years ago. You find yourself matching your breath to the slow, steady growth of the crystals. In and out. 6 sides, 6 arms, a rhythmic hexagonal pulse that transcends time and space. You do not need to understand the mathematics to feel its peace. You only need to know that the silence of the woods is built on this foundation of order. The heavy velvet curtains of the cabin seem to grow even softer as the room dims, leaving only the orange pulse of the fire and the white geometric wonder of the night. The dance continues, slow and patient, carrying the forest, and you further into the deep restorative quiet of winter. The rain of white continues outside, each flake a tiny architect completing its work in perfect six-fold symmetry. And as the night deepens, you feel yourself becoming part of this ancient pattern, your own rhythms slowing to match the eternal geometry of ice and silence. You sit perfectly still in the high-backed chair, the only movement in the room being the slow, rhythmic dance of the flames reflected in the dark glass. Outside, the storm has intensified, yet the world feels more silent than it did an hour ago. This is not just a psychological trick of the mind. It is a physical reality born of the unique architecture of the snow. Freshly fallen snow is one of nature's most effective acoustic insulators, a literal sponge for sound that transforms the entire forest into a massive open-air anechoic chamber. In the science of acoustics, we measure sound absorption on a scale from 0 to 1. A flat concrete floor is close to 0, reflecting almost every sound wave that strikes it. But a deep layer of fresh, fluffy snow can reach an absorption coefficient as high as 0.9, meaning it swallows nearly 90% of the ambient noise around you. As the flakes settle upon one another, they do not pack tightly like grains of sand or droplets of rain. Instead, their jagged six-sided arms interlock loosely, leaving vast microscopic cathedrals of empty air between them. When a sound wave, perhaps the distant call of a winter bird or the low hum of the wind, travels through the forest, it hits this velvety surface. On a hard summer road, that sound would bounce and echo, reaching your ears with sharp clarity, traveling hundreds of meters with little energy loss. But here, the sound wave enters the porous labyrinth of the snow. It becomes trapped in the millions of tiny air pockets, bouncing from one crystal face to another in a process called scattering. With each reflection, the sound wave loses a fraction of its energy, converted into infinitesimal heat through molecular friction. The wave bounces and bounces until its energy is exhausted, absorbed completely, leaving behind only silence. The snow does not just block the sound, it consumes it, transforming acoustic energy into thermal energy so small it cannot even be measured. You can almost feel the weight of this silence pressing against the cabin walls. It is a heavy quiet, the kind of stillness that makes your own breathing feel like a significant event. The jagged edges of the flakes scatter the high-frequency sounds most effectively, the sharp hisses and whistles of the world, while the deep air pockets absorb the lower frequencies, leaving behind only the lowest, most comforting vibrations. This frequency-dependent absorption is why snow-covered landscapes feel so peaceful. The irritating high-pitched sounds of civilization are removed first, leaving only the gentle rumble of distant phenomena. There is a beautiful Japanese term for this specific quiet: shinshin. It describes not just the absence of sound, but the active silencing of a place where sound used to be. It is the sound of time being suspended, of the world holding its breath. As you watch the forest through the glass, you realize that the air temperature itself is participating in this hushing. Colder air is denser, with molecules packed more tightly together, making it harder for sound waves to push their way through the atmosphere. At -10 degrees Celsius, sound travels about 6% slower than at room temperature. Furthermore, during a snowfall, there is often a temperature inversion, a layer of warmer air near the ground and colder air above. This creates a sonic lens that refracts sound waves, bending them upward and away from the earth, sending them out toward the empty reaches of space, ensuring they never reach your ears at all. The atmosphere itself becomes a sound deflector, working in concert with the snow to create this profound stillness. You are living inside a sonic cocoon, a rare interlude where the world has agreed to stop its chatter. Even the snowflakes themselves, as they fall, make no sound. Unlike the sharp patter of rain, each with a terminal velocity of about 9 meters per second, a snowflake lands with low-density grace, its impact too soft to vibrate the air in any way we can perceive. Its terminal velocity is only about 1 meter per second, falling gently like a feather. You are surrounded by millions of these silent impacts every minute, a massive ongoing gesture of peace. The world has been simplified. The edges of the trees are muffled, the sharp lines of the landscape are rounded, and the noise of the human world has been retracted into distant memory. As the room grows darker, lit only by the pulsing heart of the hearth, you find your mind mirroring this acoustic absorption. Just as the snow traps the noise of the wind, your thoughts are being trapped and softened by the rhythm of the storm. The worries of the day enter this mental landscape and find no surfaces to bounce off of. They wander into the quiet and settle, becoming part of the still white history of the night. You are not just observing the silence, you are becoming a part of it. The weight of the blanket on your lap feels like the weight of the snow on the trees, a protective, insulating pressure that allows everything beneath it to finally, truly go to sleep. As you sit by the glass, you might notice that the world outside has taken on a mysterious, ethereal hue. This is the blue hour, a brief sliver of time just after the sun has dipped below the horizon, but before the true darkness of night has fully arrived. In a snowy landscape, this hour is transformed into something even more profound. While we often think of snow as pure, dazzling white, it is actually a masterful filter of light, one that reveals its secrets only when the sun is out of direct sight. The science of this indigo transformation is a beautiful interplay of physics and chemistry. During the day, snow appears white because it reflects nearly all the visible light that strikes its surface, a quality known as high albedo. Fresh snow can reflect up to 90% of incoming light. But when the sun is between 4 and 8 degrees below the horizon, the direct golden rays can no longer reach the Earth. Instead, the atmosphere above you becomes dominated by shorter blue wavelengths. These high-energy blue rays, with wavelengths around 450 nanometers, are scattered more easily by the air molecules and the ozone layer through a process called Rayleigh scattering. This is the same phenomenon that makes the sky appear blue during the day. But now, in twilight, this scattered blue light descends upon the forest like a cool, invisible mist, bathing everything in its glow. You watch as the shadows of the pines turn from gray to a deep, rich cerulean. This happens because snow is not just a flat, reflective surface. It is made of billions of tiny ice grains that act as miniature prisms. As the ambient blue light from the sky enters the snowpack, it does not just bounce off. It penetrates the top layers. Within these layers, the ice grains perform a specific task. They preferentially absorb the longer, warmer wavelengths of light, such as red and yellow, which have wavelengths above 600 nanometers. The blue light, however, is allowed to scatter and survive. Each time a photon of light bounces off a grain of ice, it loses a little more of its red energy through selective absorption, until finally the light that emerges back to your eyes is a vivid, tranquil blue. There is a deep peace in this scientific filtering. You are looking at light that has traveled a long, indirect path through the crystalline structure of the snow before finally reaching you. If you were to dig a hole deep into a fresh drift outside your window, the color at the bottom would be even more intense, a glowing neon sapphire. This is because the further the light has to travel through the ice, the more of the red spectrum is filtered out, leaving only the purest, most calming blue behind. The world feels suspended in this cool light, a transition period that artists and photographers call the magic hour because of its soft, diffused quality. Unlike the harsh glare of midday, this indigo glow eliminates sharp contrast and harsh edges. It is a visual invitation to let your eyes rest, to soften your gaze. The deep blue sky above blends almost seamlessly with the deep blue earth below, creating a sense of weightless continuity, as if the boundary between heaven and earth has dissolved. You are sitting at the center of this indigo world, safe behind the glass, watching the science of light perform its final, most relaxing act of the day. As you watch the firelight from your cabin cast a warm orange contrast against the blue exterior, you feel a deep sense of balance. The physics of color are working in harmony. The warmth of the hearth with its long red wavelengths, the cool of the twilight with its short blue wavelengths, and the silent blue history of the snow. The blue hour is short, often lasting only 20 to 40 minutes, but its effect on the mind is lasting. It signals to the world and to your deepest biological rhythms that the day is truly over and that it is time to surrender to the long indigo quiet of the winter night. The indigo light of the blue hour begins to deepen into a true star-studded midnight. Looking out from the warmth of the cabin, the forest appears frozen and still, as if the very breath of the earth has been suspended in the cold. Yet beneath the pristine white surface of the snow, a secret, warmer world is thriving. This is the science of the thermal blanket, the remarkable ability of snow to act as one of nature's most effective insulators. While the air temperature outside your window may drop far below zero, sometimes reaching -20 or even -30 degrees Celsius, the soil beneath a deep layer of snow often remains at a steady, manageable temperature around 0 degrees Celsius. This insulating power comes from the same architecture that creates the winter silence: trapped air. Freshly fallen snow is composed of up to 95% air, held in place by the intricate interlocking arms of the ice crystals. Air is a very poor conductor of heat, with a thermal conductivity nearly 25 times lower than ice itself. This means it does not allow the warmth of the earth to escape easily into the atmosphere. Like the down feathers in a winter parka, or the specialized foam insulation in the walls of this cabin, the snowpack traps the geothermal heat rising from the planet's core and holds it close to the ground. This creates a vital microclimate known as the subniveum, a Latin term meaning under the snow. You can imagine the quiet activity happening just a few feet away from your porch, hidden beneath the drifts. In the subniveum, the temperature is stable and humid, protected from the biting winds and the extreme fluctuations of the night sky. This layer can maintain temperatures 30 or even 40 degrees warmer than the air above the snow. Small mammals like voles and mice are not hibernating. They are busy, scurrying through a network of tunnels they have carved at the interface where the snow meets the soil. They forage for seeds and dried grasses, nibble on bark and roots, all in a world that is relatively toasty compared to the frozen landscape above. For these creatures, a deep snowfall is not a hardship. It is a life-saving roof that shields them from predators and the lethal cold. The plants, too, are beneficiaries of this frozen quilt. Many of the delicate roots of the trees you see, the sleeping maples and the resilient pines, would be damaged or killed if the soil were allowed to freeze solid and crack. The repeated freeze-thaw cycles that occur in snowless winters can heave roots out of the ground and destroy the soil structure. But the snow prevents the frost from penetrating too deeply into the earth. This keeps the delicate microbial life and the roots in a state of suspended animation, rather than a deep, destructive freeze. It is a beautiful irony of nature. The very substance we associate with bitter cold is the primary reason so much life survives until spring. The snow is not the enemy of life. It is its protector. As you settle further into your chair, feeling the steady warmth of the hearth on your skin, you realize you are part of this same biological story. The cabin, with its heavy glass and insulated timber, is your own subnivium. You are tucked away, safe and warm, while the great thermal blanket of the storm continues to build outside. You can almost feel the earth below the cabin exhaling a sigh of relief as the snow grows deeper. With every inch that falls, the insulation becomes more effective. The world below becomes more stable, and the deep metabolic rest of the forest becomes more secure. The night is cold, but the earth is warm. The air is harsh, but the ground is protected. And you are drifting closer and closer to that same protected peace, wrapped in your own layers of warmth, secure in the knowledge that the world knows how to take care of itself. As the cabin remains bathed in the low, pulsing amber of the fire, we turn our minds once more to the world outside the glass, specifically to a single solitary flake beginning its descent. To understand the peace of a snowfall, one must understand the unhurried nature of this journey. A typical snowflake, despite its appearance of fragile speed in a gust of wind, is a remarkably slow traveler. On average, it takes roughly 45 minutes to an hour for a snowflake to complete its odyssey from the high, cold clouds, often at altitudes of 3 to 5 kilometers, to the quiet floor of the forest. This hour-long descent is not a straight line, but a drifting, swirling meander. Because a snowflake weighs so little, often only about 10 to 20 micrograms, roughly 1/10,000,000th the weight of a paperclip, it is at the complete mercy of the air's hidden architecture. As it leaves the cloud, the flake enters a world of invisible currents and turbulent eddies. Scientists have discovered that regardless of its shape, a snowflake's path follows surprisingly predictable physical patterns. The flake does not merely fall. It tumbles through the air in a complex dance, influenced by aerodynamic forces. Its flat surfaces catch the air, causing it to spin and rotate. It swirls and accelerates in response to the air's turbulence, sometimes moving horizontally as much as vertically. The flake can be caught in upward-moving regions of air, thermal updrafts that can extend its journey for several additional miles from its place of birth. It loiters in the sky, suspended between heaven and earth, riding invisible waves of atmosphere. Imagine that hour of drifting. For 60 minutes, the snowflake is a passenger of the atmosphere, traveling at a gentle terminal velocity of about 1 to 1.5 meters per second, roughly the speed of a leisurely walk. During this time, it is a frozen letter sent from the sky, a phrase coined by the physicist Ukichiro Nakaya, who devoted his life to understanding snow. The flake's intricate structure carries a detailed record of the air it has touched. Every second of that hour, the flake is experiencing minute changes in its environment. A tiny increase in humidity, perhaps only a few percent, adds a delicate, lacy branch to its 6 arms. A sudden drop in temperature, even just a degree or two, sharpens those branches into fine, needle-like points. The flake may pass through a region of rimming, where supercooled water droplets freeze instantly upon contact, coating its surface with a frosted glaze. It may collide with other crystals, joining together to form larger aggregate snowflakes. Each experience modifies its structure, adding to its unique biography written in ice. Because each flake follows a slightly different individual path through these fluctuating layers of temperature and moisture, it encounters a unique sequence of conditions. This is the scientific reason behind the famous truth that no two snowflakes are exactly alike. Each one is a physical map of a specific 60-minute journey through the sky, a journey that involves countless micro-decisions made by physics, countless collisions, partial meltings, and regrowths as it moves through warmer and colder pockets of air. As you watch the snow from your window, you are witnessing a massive synchronized arrival of these hour-long travelers. Some may have begun their journey in clouds that have already drifted far beyond the horizon by the time the flake finally reaches your porch. There is a profound, rhythmic patience in this process. The atmosphere does not rush its delivery. The flakes do not hurry to land. They surrender entirely to the slow, swirling laws of fluid dynamics, moving with a grace that suggests there is nowhere else they need to be. They are content to drift, to tumble, to wait. Your own sense of time begins to sync with this 60-minute descent. You are not thinking of the minutes as they pass, but experiencing them as a slow, continuous drift toward a resting place. Just as the snowflake finally touches the ground and integrates into the deep, white silence of the snowpack, your own thoughts are settling one by one into the warmth of the cabin. The long journey of the sky is over, and the long rest of the night has truly, finally begun. As you watch the snow accumulate against the glass, you realize that the white expanse outside is not just a uniform mass, but a vertical library, a frozen record of every moment that has passed since the storm began. In the science of glaciology and snow physics, a snowbank is viewed as a series of distinct strata or layers, each one representing a specific chapter of the weather's history. If you were to look at a cross-section of the snow currently piling up on your porch, you would see a timeline of the night's atmosphere preserved in the changing texture and density of the crystals. The bottommost layer, resting directly against the wood of the deck, represents the early evening when the air was perhaps slightly warmer and the flakes were large and heavy, falling as broad stellar dendrites. Above that, you might find a layer of fine powdery diamond dust from the midnight hour when the temperature plummeted, creating smaller, sharper crystals that pack more tightly together. Every shift in the wind direction, every fluctuation in the humidity of the sky is recorded here in exquisite detail. A thin, icy crust within the bank might tell the story of a brief moment when the cabin's warmth radiated outward, melting the surface layer ever so slightly, only for it to refreeze as a translucent seal when the air temperature dropped again. Each layer is a page in the book of the night. This layering is a process of constant metamorphosis. Even after a snowflake lands and finds its resting place, it does not remain unchanged. The science of snow metamorphism describes how the sharp, lacy arms of the dendrites gradually round off over time, a process driven by sublimation and recrystallization. Driven by the subtle temperature gradient between the warm earth below and the cold air above, water vapor moves within the snowpack itself. Molecules evaporate from the tips of the crystals and redeposit in the hollows, smoothing sharp edges and filling gaps. This vapor travels from the bottom layers towards the top, recrystallizing into larger, more stable grains over days and weeks. It is a slow internal migration, a quiet rearrangement of matter that happens in the absolute darkness beneath the surface. The snowpack is alive in its own way, constantly reorganizing itself, seeking equilibrium. You lean closer to the window, noticing how the layers seem to glow where the hearth light hits them. The snow is not just white. It is a complex lattice of light-reflecting surfaces that change as the layers settle under their own weight. This settling is part of the snow's natural rhythm of sintering, a process where individual crystals bond together at their contact points, turning a pile of loose flakes into a structurally sound and cohesive blanket. It is as if the snow is knitting itself together, becoming stronger and more protective with every passing hour. The process can increase the snow's density from 50 kilograms per cubic meter when freshly fallen to over 300 kilograms per cubic meter after weeks of settlement. There is a profound sense of deep time in this frozen stratigraphy, even if the record only covers a single night. Just as geologists look at the layers of stone in a canyon to understand billions of years of Earth's history, you can look at the layers of the storm to understand the history of this winter evening. These layers hold the memory of the wind's direction, the sky's moisture content, and the forest's silence. They are a physical manifestation of patience, layer upon layer of quiet effort, building a foundation of rest that will endure until the first thaw of spring. As you sink back into your chair, the idea of these crystalline archives brings a quiet order to your thoughts. You are resting on top of a world that remembers. Every breath you take is mirrored by the slow internal settling of the snowbank outside. The night is not just passing, it is being recorded in the white rhythmic layers of the earth. And you are part of that steady, unhurried history. The fire burns low, the snow builds high, and the record of the night grows deeper and more peaceful with every falling grain. In the deep, frozen middle of the night, a strange and ethereal process begins to take place, a form of scientific vanishing known as sublimation. As you sit by the hearth, watching the orange embers pulse like a slow heartbeat, you might imagine that the only way for snow to disappear is through the chaos of melting. But in the dry, cold air of a true winter night, the snow has a much more poetic way of returning to the sky. Sublimation is the process where a solid turns directly into a gas, skipping the liquid stage entirely. It is as if the snowflake simply decides to become a ghost, drifting back into the atmosphere without ever leaving a trace of dampness behind. The science of this sublimation drift is driven by a delicate balance of energy and vapor pressure. Even in the freezing cold, the molecules on the very surface of a snowflake are in constant microscopic motion, vibrating with thermal energy. If the air outside is dry enough, with a relative humidity below saturation, and the wind is just a whisper, some of those water molecules gain just enough energy to break free from their hexagonal bonds. They do not collapse into a puddle. Instead, they launch directly into the air as invisible water vapor, a process that requires about 680 calories of energy per gram of ice. You could watch a snowbank for hours and never see it happen. Yet over the course of a long, clear night, several millimeters or even inches of snow can simply evaporate into the thin air, reclaimed by the atmosphere that birthed them. There is a profound, airy lightness to this concept. It tells us that even the most solid-looking drifts are in a state of constant, graceful transition. The snow is not just a heavy weight on the Earth. It is a circulating part of the planet's breath, part of the great water cycle that has been turning since the oceans first formed. As the vapor rises from the forest floor, it carries with it the absolute purity of the ice it left behind. This is how the atmosphere stays hydrated during the deep freeze, ensuring that the cycle of the clouds can continue even when the rivers are locked in ice. It is a system of recycling that requires no heat, no noise, and no visible effort, just the patient passage of time and the subtle gradients of temperature and humidity. You watch the frost patterns on the corner of the window pane, realizing they are the reverse of this process. While the snow outside is sublimating into the air, the vapor inside the warm room is depositing itself onto the cold glass, turning from a gas directly back into solid crystal, creating intricate fern-like patterns. It is a beautiful symmetrical exchange, a conversation between states of matter. The world is constantly shifting between the seen and the unseen, between the solid and the spirit. This scientific drift reminds you that nothing is ever truly lost. It only changes its form to meet the needs of the moment. As your eyelids grow heavier, mirroring the slow descent of the temperature outside, you find comfort in this idea of the vanishing white. You do not need to hold on to the day, just as the snow does not need to hold on to the ground. You can allow your own thoughts to sublimate, to let the heavy, solid worries of the afternoon turn into light, airy dreams that drift away into the dark. The room is warm, the glass is cold, and the air is filled with the invisible movement of 1,000 returning molecules. Everything is in motion, yet everything is still. The forest is exhaling its winter coat back to the sky, one molecule at a time, in a rhythm as old as the earth itself. You are safe in the middle of this great quiet circulation. There is no rush to wake, no rush to act. There is only the drift, the breath, and the slow crystalline return to the source. The fire has finally reached its end, leaving only the faintest, warmest scent of wood smoke and the deep, pulsing memory of the embers. The room is now almost entirely dark, the heavy glass windows serving only as mirrors for the absolute stillness of the forest. Outside, the storm has reached its peak of silence. The infinite white has covered every path, every stone, and every branch, smoothing the edges of the world until there is no beginning and no end to the landscape. This is the final stage of the night's science. the state of total equilibrium. The atmosphere, the earth, and the snow have found a perfect balance. The thermal blanket is at its thickest, holding the warmth of the planet securely in the dark. The trees are in their deepest metabolic withdrawal, their life forces held in a quiet, unmoving center, conserving every precious calorie of energy. The air pockets in the snow have absorbed the last traces of sound, leaving a quietude so profound it feels as if the forest is no longer made of matter, but of dreams and memory. You are no longer observing this rest. You are submerged within it, dissolved into it. As your awareness begins to dissolve into this infinite white, think of the vast cycles that brought you to this moment. The water that drifted from the clouds to form these flakes has been part of the earth for billions of years. It has been vapor in the primordial atmosphere. It has been rain on ancient continents. It has been ice in glaciers that carved valleys. It has flowed through the veins of dinosaurs and the roots of the first forests. And now it is the protective silence that holds your home. This cycle does not rush, and it never fails. It moves with the slow, relentless patience of the tectonic plates, the rotation of the planet, and the turning of the stars. You can surrender to this rhythm now, knowing that the earth will continue to breathe, the snow will continue to protect, and the night will continue to hold you in its safe, crystalline embrace. There is nothing left to understand. There is no more science to follow. The journey through the geometry of crystals, the absorption of sound, the filtering of light, and the warmth of the frozen earth has completed its work. You are now a part of the record, a quiet pulse in the long, white history of winter. The weight of your blankets is the only sensation remaining, a gentle grounding pressure that tells you the journey is complete. Your breathing has slowed to match the rhythm of the sublimating snow. Your heartbeat has synchronized with the settling of the crystals. You are part of the infinite white. The words are fading now, drifting away like the sublimation vapor returning to the dark blue sky. Let them go. Let the forest take over. Let the infinite white expand until it fills your vision with peace. The fire is gone, the room is warm, and the silence is infinite. You are drifting, you are sinking, you are home.